Okay, so good morning, students. Am I audible?
Yes, sir.
Okay, so I will be starting the next topic. Okay, because Monday you are having exam, but unfortunately, I was supposed to start this topic 1 week ago, but due to the administrative work of our college for the NAC accreditation, okay, so we were working on it, so I was unable to take the classes. Okay, but I will try to cover the syllabus before time. Okay, so that is why I'm just giving you the brief introduction to this particular topic, okay, because this is quite scoring. This board plot subject is quite scoring, okay, and that is why this is very important for you. Similar to root locus, because root locus, board plot, Nyquist plot, okay. So these three things are very important for a control system exams as well as for your future studies, okay. Now, board plot, it is basically one of the frequency domain, okay, for the frequency domain plot, because in board plot basically what we do, similar to the for Nyquist, I don't know Nyquist has been started or not, but similar to Nyquist, okay, board plot is also performed on a system to observe its stability. Okay, now how to represent any transfer function equation, okay, in the frequency domain, that first of all you have to know. Okay, so I will just show you. Okay, so if you have any equation, suppose GS, okay, you have an equation GS equals to, suppose S plus 5 by S square, S plus 3, or 2S plus 5. You have a transfer function like this. Now, for frequency domain, okay, we call it frequency domain. What we do, we represent this S. S is a complex number. X is equals to sigma plus j omega. Okay, sigma plus j omega. But in frequency domain, we generally ignore the sigma part. Okay, we ignore the sigma part, we consider it to be 0. That is why we write S equals to j omega. Okay, this is the frequency domain analysis. So what we will do, we will replace this Gs as j omega. Replace S by j omega. Okay. So the equation, whole transfer function will be like this: j omega plus 5. Okay, j omega square, j is the complex number, okay, here it will be j omega plus 3, and this one will be 2 j omega plus 5, like this. It will be represented in this way. This is the frequency domain. Now, in board plot, what you have to do, whenever a transfer function is given in S domain like this, you have to convert into frequency domain, and you have to represent in this way, like 1 plus st, or in S domain or in frequency domain 1 plus j omega t. This is the method. So first step number 1 will be, whenever you have a transfer function in S domain, you will convert into a frequency domain, replace S by j omega. Number 2 step will be, whatever term you have to represent in this form, 1 plus j omega t. If you see carefully, this particular step, this is after the frequency domain. Okay, now over here you can see this step is okay, because okay, these two steps are not okay because they are not in the form of 1 plus j omega t. Okay, these two steps actually 1 plus j omega t, no, it is not in that form. So what you have to do, you have to write in this way, as well as this term also. These three terms are not in the form of 1 plus j omega t. So what you have to do, you have to take 5 common, okay, from the numerator. What you will get, you will get 1 plus, okay, you will get 1 plus j omega by 5. Okay. Then in the numerator you have j omega square, so no problem. It is a pole at the origin, two poles at the origin. Okay, so type 2 system. Then next you can see you're having j omega plus 3, so you have to take 3 common. Then it will be 1 plus j omega by 3. Okay. Then the third term will be, you have to take 5 common, so that it becomes 1 plus 2 j omega by 5. Okay. Okay. Now you can see 5 is getting cancelled. These are the gain. These are the k value. These are the nothing but the k values. And this term, okay, this 1 by 3, 1 by 5, okay, this one, because you can see if you concentrate on this term physically, you can see it is 1 plus j omega by 3. That means if you compare with this, it concludes that t is equals to 1 by 3. So it is 1 by 1 plus j omega t, that means it is 1 plus j omega by 3. Okay, 1 plus j omega by 3. So you have to write in this form. Okay, so this 1 by 3 is nothing but the t. Okay, 1 by 3 is nothing but the t. Okay, so this is the actual form. So now our transfer function will be written in this form. It is, if you simplify it, it will be 1 upon 3. Then it will be 1 plus j omega by 5 divided by the rest term is there, j omega square. Okay, then 1 plus j omega by 3 multiplied by 1 plus 2 j omega by 5. Okay, this is your ultimate equation. Now you can proceed with this ultimate equation. Okay, you have to proceed with this ultimate equation. So this is the red color is the ultimate equation. Okay, you have to form in this way. Now you can start with the board plot. So this is the steps. So first of all, whenever you will have a transfer function in S domain, you will convert into frequency domain and for simplify it in this particular format, that is 1 plus j omega t. Okay. All right. Now, what is actually, how to represent a board plot? Okay. A board plot is basically has two parts. One is the magnitude plot and one is the frequency plot. Okay. Now there are few parameters. Okay. Now parameters, I mean that the different terms are there. Okay. First of all, let me introduce to the uh, semi-log paper. Okay. Okay. This is a semi-log paper. Now in semi-log paper, there are different types of semi-log paper available in the market, but we have to use a 5-cycle semi-log paper. What is 5-cycle? 5-cycle means that you can see it is called 5 cycles, that is 1 by 10. That is, this is one cycle, this is one cycle, okay, this is one cycle, second, okay, third, fourth, fifth. 5 cycles are there. Okay, the 5 cycles semi-log paper is required. Now, this is basically semi-log means it is a log paper actually. Okay, it is kind of a log paper. Why we are using log paper? Log means logarithm. Okay, logarithm paper, semi-logarithm paper. So why we are using? Because in a particular board plot we have two types. We generally represent two types of plots because the system stability can be judged based on those two plots, because it is necessary to plot two different type of you can say make two different type of plots in a single graph. and from that two plots we can get one relationship. From that relationship we will able to conclude that the system is stable or not. Okay. Now in a graph, obviously it is a two-dimensional graph, so there is a x-axis, there is a y-axis. Okay. Now the two plots are there, which I have already told you. First one is the magnitude plot. Magnitude plot. Okay. Magnitude plot means, suppose you have a transfer function that is GS. Okay, it is GS. GS is there. Now we represent GS as G J omega, as I've told you. Okay. It can be anything. So the magnitude plot means you have to find the magnitude first. That will be using this particular formula. Okay, that is 20 log base 10, then the mod of the transfer function J omega. Okay, mod of the transfer function of the J omega. Okay, this is the magnitude plot. And the second plot is the phase plot. Phase plot. Phase plot means you have to find out the angle particular transfer function. Now, whether you have to find the magnitude of the entire transfer function and the angle of the entire transfer function, actually it is not possible to determine the magnitude of the entire transfer function at first instantly. Okay, so the technique is that we divide every term in a transfer function into, we take different, that means suppose we have a transfer function of say gain value 5, then s plus 3, as I've told you, divided by x square plus s plus 4. We will take each term individually. We will take 5 first, then s plus 3, then 1 by s square, then 1 by s plus 4. We will take individually, then find the magnitude plus and phase plot, then we will converge them all, combine them all to get the total magnitude plot. Okay, that I will show you step by step. Now first of all, these are the two plots which are required. Now both the plots has to be done or made on this particular graph. Okay. Now first of all, we need to know that there are two axes. So what do they represent? X-axis is common. X-axis is for omega, frequency. That is rad per second. It is frequency. It is common. Now, in the y-axis, based on the two plots, magnitude plot and phase plot, magnitude, whatever unit you will get, okay, obviously you will get some unit. Unit will be in decibel. Unit will be in decibel because you are finding log base 10. So, your unit will be decibel. And this unit angle will be degree. Okay. Now, in the graph it is told 5 cycles. 5 cycles means every cycle means it is kind of a one decade. That means this is 1, 2, 3, 4, 5, 6, 7, 9. Then we have 10. 10, then 10 to the power 1 actually. Then 10 to the power 2. Then 10 to the power 3. Like this 10 to the power 10. Okay. So it is actually 1 to 10. Then 10 to 100. So 10, 20, 30, 40, 100. Then 100, 200, 300, 400, 500. At a 10, 1000. Then 2000. Then 10,000. Okay. Then 1 lakh, 2 lakh, like this. This is kind of decade. So this is one decade. This is another decade. This is another decade. Another decade. Another decade. 5 decades are there. 5 decades. Decade means dashak. Okay. In Hindi. 5 decades. So I can understand there are too many information. So first of all, you have to remember this, that whenever you have a transfer function, you represent the S domain into j omega and write the equation and then simplify as 1 plus j omega t. You form that first, Then you start the board plot. So for starting the board plot, you need to have a semi-log paper like this with 5 cycles. That means 5 decades. X-axis will be omega, radian per second frequency, and y-axis in the same plot you have to draw one magnitude plot. So you will divide it like this. You will divide the plot into two parts. In the first part you will draw the magnitude plot, and second part you will draw the phase plot. Okay. Magnitude plot, the unit will be in decibel, phase plot will be in degree. Okay. And in magnitude plot, you have to take one reference axis. Reference axis. You first draw that line in between. Okay. That will be 0 decibel, 0 dB. Okay. 0 dB, 0 decibel. This is next step. Okay. Then the, one second. Okay. Yes, for the phase plot, okay, you have to take the angle to be 180 degree. Okay. The reference will be 180 degree. Okay. So 180 degree, or rather we can say minus 180 degree. Okay. So we will come to the phase plot later. First of all, let us concentrate on the magnitude plot first. Okay. Because first of all, you have to understand the magnitude plot, how to take the total magnitude plot by adding all the magnitudes of the individual terms. Then the same thing will be performed for the phase plot. So if you understand magnitude plot, you won't take too much time to understand the phase plot. Okay. First of all, uh, if I talk about the magnitude plot, so if I take an example that a transfer function, okay, GS, okay, as I've told you, the transfer function can be having different terms. Okay, suppose it is having uh, 10, okay, 10, then you are having uh, 1 plus s by 2. Suppose we are writing in this form 1 plus st. Okay, if it is not given, then you have to convert it into this. Okay, and just directly writing it in this way. Next is s square, then we have 1 plus s by 5. Now over here we have 4 terms: number 1, number 2, number 3, number 4. Now the, okay, if I represent a different color, that will be easier. Number 3, number 4. Now the terms which are being circled in the red color are in the numerator part. Okay, numerator part, and this is the denominator part. Okay, the numerator part, we generally have the gain in the numerator part. This is called the gain. Okay, now next step will be you have to represent in the j omega. Okay, frequency domain. You have to represent in the frequency domain. So frequency domain will be 10 will be as it is, then 1 plus j omega by 2, then j omega square, 1 plus j omega by 5. ठीक है? Okay. Now the first term, so rather we have to concentrate on this one than the previous one. Okay, so we have to concentrate on this one. So this is the numerator and this is the denominator. So talking about the gain will be same as it is. This is also gain. So as we have used the formula of finding the magnitude, so we will take individual terms. Okay, each term individually and take the magnitude first. Suppose for m1 first term it is 10, so we will write 20 log base 10 10. Okay, so now who can tell what is the value? Anyone? It will be a constant term,
20.
20.
20. So it will be 20 decibel. Okay, 20 decibel. So what you have to do, one second, I need to take this also, otherwise you will not be able to. Uh, okay. Now over here, since we are concentrating on the magnitude plot only, so what we will do, we'll take this as, suppose this is the zero line. Okay, this is zero. You will draw one zero line over here, 0 decibel. Okay, this is 0 and we will call it 0 decibel. Okay. Now we will count in this way. Suppose we don't know what is the total magnitude. So suppose this is 10, 20, or suppose this is 5, 10, 15, 20. Okay, this is 5, this is 10, this is 15, 20. So 20 decibel. That you can calibrate of your own. Okay, this is 20. So you will draw a straight line with 20. Okay. Okay, 20. So this represents the value k. This is, we will write in this way. This is k. K k equals to 10. And obviously we can see that this is 20 decibel. So you don't have to write that 20 decibel. It is already written over here. You have to write over here that it is k equals to 10 with an arrow. Okay, you can show this also, but it's not necessary, because at the end, okay, whenever you will be plotting the main graph, cumulative graph, then you have to erase all these things individually. Okay. Just for your understanding, I'm just written over here that it is k equals to 10. Now, the next is this term 1 plus g omega by 2. So, talking about m2, okay, 1 plus g omega by 2. So, now this term is basically little bit, you cannot determine by using directly 20 decibel. Okay, that was in using that particular log base 10. Okay, because it will be like 20 log base 10, then mod of 1 plus g omega by 2. Okay. So there is a method. So generally the magnitude is not represented in this way. It is represented in the form of a slope. Okay, it is represented in the form of a slope. So we call it a simple zero. This one, this is called a gain, and this is called a simple zero. It is called a simple zero. Simple zero means it is 1 plus j omega by 2. So it is a zero because it is a numerator part. So it is a simple zero. A simple zeros are represented in magnitudes are not calculated because we only have to find the slope. Okay, our target is you have to find the slope. Okay, because this is the this particular magnitude what we have obtained from the gain, that is k equals to 10. The slope is 0. Slope means that it will be like this. It will like this, or it is going upwards. Okay, or like this. This is called slope in board plot. This one is a straight line, horizontal line, parallel to the 0 decibel line. So it is having no slope. So gain doesn't have a slope. But poles and zeros have slope. If you have a simple pole like this, there is 1 plus j omega by 2, then the slope will be 20 decibel per decade. This is called the slope. Okay. This is called the slope, which means that if you take this particular board plot, okay, this, see, I have told you this is 1 decade, this is 1, this is 10, 10, this is 10 to the power 1 actually, this is 10 to the power 10, sorry, this is 10 to the power 2 actually, sorry. 2, this is 10 to the power 3, this is 10 to the power 4, this is 10 to the power 5. Okay, this is 10 to the power 0 actually. So 1. So now slope means that 20 decibel per decade. 20 decibel per decade means that per decade means this is one decade, this is another decade. So you have to represent in this way that 20 decibel. Suppose okay, let me show first of all how to represent. Now 20 decibel per decade you cannot get instantly. So there is a frequency over here. This is a term 2 over here. Okay, directly 20 decibel per decade you can do for 1 by x square or s. Okay, so let me show you step by step. So that will be easier for you. So let me show in this way in another slide. Okay. Now forget about the previous transfer function. From the previous one, we only have the value of gain. Okay, we have seen that gain has magnitude but no slope. The magnitude is constant. Okay, we have obtained this. We have got this. Okay. Now, suppose there is a transfer function. Okay, g omega, which is suppose a numerator part. Forget about the denominator. Something is there in the denominator. We have a gain k, and we have s, only s. That means 0 at the origin. Only s means what? 0 at the origin, and 1 by s means pole at the origin. So suppose we have s only. So s means, suppose this is called a 0 at the origin. Okay, so this is called 0 at the origin. So 0 at the origin is also having a particular slope. It is having a slope. What is that slope? The slope will be, if you take this particular semi-log paper, okay, semi-log paper, suppose I am showing over here, it will have a slope of same 20 plus 20 decibel per decade. That means for numerator, if you are having a 0 at the origin, 20 decibel means that this is 20, suppose. Okay, this is 0, this is 20. So in one decade, it will be traveling like this. Okay, and it will travel in this same way. This is the slope. Okay, let me show in a different way. That will be better for you, because it is very difficult, because it is the best if you have a physical class with a blackboard, because the pen tab is not, I don't know why it is not supported with my laptop due to some issues. Okay, 20 decibel means, suppose, forget about the phase plot, I am talking about the magnitude plot. Suppose this is uh, the zero line. Okay, this is 0 decibel. Suppose this is suppose this is 5, or you can say this is 5, this is 10, this is 20, 25, or rather I would say this is 10, 20, okay, 10, 20, 30, 40, 50, 60. Okay, this is minus 10, this is minus 20, this is minus 30, this is minus 40. Okay, minus 40, suppose, because this is not the center one. Okay, so now this is 0 decibel. Alright, now we will plot 20 plus 20 plus 20 decibel per decade. We want to plot it. How we will do? This is 0, this one is 0. Okay, this is plus 20. So this is one decade. This is 1, this is 10, this is 10 to the power 2. Okay, 10 to the power 2. This is 10 to the power 1 cycle, 2 cycle, 3 cycle, 4 cycle. Sorry, this is 10 to the power 10 to the power 2 3. This is 10 to the power 4. This is 10 to the power 5. So this is one cycle. So from 0 to 20, you will cut a line, and from 20 to 40, you will cut a line. You will see that from 0 to 20, you are covering one decade. Okay, because the 0 will be here. The 20 where you have to cut, you have to cut where the x-axis is 10. And from 20 to 40, you will see you are also traveling one decade. Then 40 to 60, you are traveling another decade, and so on. So you will draw a straight line. This line is 20 decibel per decade. 20 decibel per decade. This one, 20 dB per decade. This is for numerator. Now suppose if the numerator is s square, then it will be 40. Oh, not s square actually. It should be j omega actually. Same thing, because if it is s, then we have to write in the form of j omega. Now suppose it is j omega square. That means it was s square. So you have written j omega square. You have written it will be 40. That means if for j omega the slope is plus 20, for j omega square the slope is plus 40 decibel per decade. For j omega cube, it will be multiplied with 20, 60. For j omega to the power 4, it will be 80, and so on. Okay, so it is squares. If it is square, j omega square, so it will be plus 40 dB per decade. So for that, what you have to do, you have to cut a line in this way, that this is 0, this is 40. So 40 for one decade, then 80 for another decade. So if you have two lines, you can join them like this. Understood the difference? This is 40. This one, the blue one is plus 20 dB per decade. Why? Because you are traveling 20 decibel for each decade. And the green one is 40 dB per decade, because you are traveling 40 decibel for each decade. Okay, it is not shown over. You cannot show it because the graph has limitation. So we just, if you draw this straight line taking 2 points, that is indicates that yes, the slope will continue, because it is a straight line. It is not a curved line, so it will be unanimous, continuous. You can easily plot that. Okay, this is for the simple. Oh, sorry, pole 0 at the origin. Now, if you have a transfer function where it is 1 by j omega in the denominator, that is pole at the origin. Okay, similar to this one, it is j omega square. जो एग्जांपल में हमने पहले लिया था 1 by स्क्वायर, दैट मींस 1 by j omega स्क्वायर. अगर मान लो कि 1 by j omega है सिर्फ, ठीक है, 1 by j omega, तो उसके लिए उसका स्लोप होगा -20 dB per decade. सेम थिंग, ओनली इट विल बी माइनस. इन प्लेस ऑफ प्लस वी विल यूज माइनस. तो यहाँ पर कैसा होगा, माइनस के लिए नेगेटिव डायरेक्शन में जाना पड़ेगा, नेगेटिव एक्सिस में. We have to go for in the negative axis. So what we will do, we will do the same thing. This is 0, this is minus 10, this is minus 20. So we will cut a line over here, point over here for one decade, and we will join it. We will join it. Blue color, yes. As if 40 में, हाँ ये देखो, ये जब -20 था तब ये 10 को कट कर रहा है, -40 है. सो कहाँ पर कट कर रहा है ये 10 20. I think this one will be 10 to the power 2. Okay, so it should be, the slope should be same. So 20 to -40 should be 10 to 100. Okay, so this is the -20 decibel per decade. और अगर यहाँ पर ये होता, स्क्वायर होता, तो 40 हो जाता. सेम थिंग जैसा इसके लिए है वैसा ही माइनस हो जाएगा पोल के लिए. ओके, पोल एट द ओरिजिन के लिए. सो फॉर 1 by s square, that means 1 by j omega square, it is two poles at the origin. The slope will be -40 dB per decade. That means this is 0, Okay, this is 0, this is 40, so you will cut over here and will join the line. Same thing. -60 होगा अगर एच एस क्यूब हुआ, एच टू का 4 -80 होगा ऐसा, ठीक है। अभी सिंपल पोल के लिए क्या होता है? सिंपल पोल मतलब कि यहाँ पे ये वाला सिंपल जीरो जो है उसके लिए भी प्लस 20 पर टिकट होना चाहिए, लेकिन ऐसा स्टार्टिंग से नहीं होगा। स्टार्टिंग से सिर्फ होता है कब? जब जीरो एट द ओरिजिन हो या पोल एट द ओरिजिन हो। जीरो एट द ओरिजिन होगा तो प्लस 20 dB पर टिकट, पोल एट द ओरिजिन होगा तो -20 dB पर टिकट। अगर मोर देन वन पोल टू दी पावर एक्सपोनेंट ऑर्डर बढ़ रहा है तो मल्टीप्लाई हो जाएगा। लेकिन फॉर सिंपल पोल एंड फॉर सिंपल जीरो वी विल नॉट यूज दिस मेथड। There will be slope, but the slope will come after a certain time. What is that? After a certain frequency. That is called the corner frequency. उसका एक नाम है जिसको कहते हैं हम corner frequency. Corner frequency. Corner frequency is represented by this term. This is the last one I will discuss and I will end the class. Corner frequency. यहाँ पर corner frequency क्या है? Corner frequency को यहाँ ऐसा लिखेंगे कि ओमेगा। ओमेगा का मतलब क्या है? 2 पाई एफ। 2 पाई एफ मतलब 2 pi by t. Generally, omega is inversely proportional to t. We all know. That is why we will write omega equals to 1 by t. Which means that omega t is equals to 1. Okay. Omega t is equals to 1. Okay. तो t मतलब क्या? t मतलब ये जो है ये t है. 2 is the t over here. So in our case it is 1 by j omega by t, where t is equals to 2. So omega into 2 equals to 1, that is omega equals to 1 by 2. It is 0.5. ठीक है, it is 0.5. So 0.5 मतलब यहाँ पर आपको 0.5 फ्रीक्वेंसी ढूंढना है। ठीक है, ये 1 है, ये 0 है। जनरली 0.5 होता नहीं है, ठीक है, ज्यादा ही होता है। मैंने यहाँ पर लिखा है। अगर तुम लोग अगर एग्जाम में प्रॉब्लम सॉल्व करोगे तो देखोगे कि यहाँ पर जनरली 0.2 0.5 ऐसा रहता है। ठीक है, अगर 0.2 मान लिया कि 0.2 है, ठीक है, तो अगर 0.2 रहा, ये वाला 0.2 है मान लो, तो if it is 0.2, so it will be how much? It will be 5. It will be 5. That means the corner frequency it is 5 radian per second. अब कहां पर है ये देखो, ये तो रेडियन पर सेकंड था, याद है, ये रेडियन पर सेकंड ओमेगा था, एक्स एक्सिस ओमेगा है, ओमेगा को रिप्रेजेंट करते हैं हम लोग एक्स एक्सिस, रेडियन पर सेकंड। तो 5 मतलब कि ये 1 से 10 है, तो ये वाला 5 होगा, ये वाला 5 होगा, ये वाला लाइन 5 है, क्योंकि ये 1 है, 1 2 3 4 5 के 10 हुआ, तो ये 5 है। ठीक है, तो ये 0 से नहीं शुरू होता है, 1 से शुरू होता है। ठीक है
सर, स्क्रीन शेयर नहीं है।
बंद हो गया क्या? कब बंद हुआ?
यस सर।
अभी बंद हुआ क्या?
Yes, sir.
ओके, अभी दिखा दे रहा है?
यस सर।
Yes, sir.
Okay, so in the actual exam, okay, in the actual exam, generally the equation will be like this: 1 plus s by 0.2, okay, 1 plus s by 0.5 ऐसा रहेगा। ठीक है, तो 1 by j omega by 0.2, 1 plus j omega by 0.5। So if it is like that, so that means 1 plus j omega by t, so t is 0.2 in our case, this is 0.2, okay, So omega t equals to 1, so omega 0.2 equals to 1, so omega equals to 1 by 0.2, so omega is 5 radian per second. So this is in the x-axis. You can remember we have represented that x-axis means radian per second, the frequency. Okay, so x-axis starts from here. Okay, it is starting from here 1 to 10, so this will be 5. So this line is 5. Okay, so you don't have to represent this one. Okay, this is 5. So our line will be like this. We will draw again from 0 to 5 a straight line. Then from 5 we will plot the plus 20 dB per decade slope. तो मतलब सेम यहाँ पर जो था, यहाँ पर भी हम लोग जब पोल को जीरो को देख रहे थे, ओरिजिन पे जीरो जो था तो 20 dB पर डेकेड हो रहा था. अगर एस स्क्वायर है तो 40 dB पर डेकेड. यहाँ पर भी सेम है, यहाँ पर भी सेम है. यहाँ पर भी तुम लोगों को जो सिंपल पोल है, सिंपल जीरो है, उसमें भी प्लस 20 dB पर डेकेड होगा, लेकिन कॉर्नर फ्रीक्वेंसी के बाद होगा. मतलब कॉर्नर फ्रीक्वेंसी का 5 है, 5 तक लाइन खींचोगे, फिर 20 dB पर डेकेड. अब कैसे करोगे? वेरी सिंपल. ये 5 है तो 5 का डेकेड क्या हुआ? 50. उसका डेकेड क्या हुआ? 500. तो 5 से 50 तक स्लोप 20 dB होना चाहिए. तो ये 5 है तो उसका डेकेड क्या होगा? 50. तो ये 0 है तो 20 कहाँ पर है? ये. तो 50 मतलब ये वाला लाइन अगर खींचोगे, ये वाला, ये 20 dB पर होना चाहिए. 20 dB है क्योंकि ये लाइन 20 dB है ना, मैक्सिमम मैग्नीट्यूड का. और फ्रीक्वेंसी जो है 5 से शुरू है, तो 5 से 50 फ्रीक्वेंसी में 20 dB का फर्क होना चाहिए. तो यहाँ पर लाइन खींच दो. तो कैसा हुआ? स्ट्रेट लाइन पहले था कितना तक? कॉर्नर फ्रीक्वेंसी तक. फिर जाके 20 dB पर डेकेड का स्लोप हो गया, प्लस 20 dB पर डेकेड. ओके, ऐसा हुआ है. ठीक है, समझ में आया? Understood up to this? Have you understood that how to plot 10 gain and then the simple 0 and 0 at the origin, 0 at the pole? Same process will be followed for this term. 1 by ये तो समझ में आ गया. अभी j ओमेगा स्क्वायर कैसे होगा? माइनस 20 dB पर डेकेड होगा. ठीक है, और ये कैसे होगा? ये वाला कहा गया, हाँ, 1 प्लस जी ओमेगा बाई 0.5. ये भी सेम होगा. 0.5 मतलब फ्रीक्वेंसी क्या आना चाहिए? कॉर्नर फ्रीक्वेंसी 1 बाई 0.5. तो ये होगा 2. ठीक है, तो 2 तो मतलब क्या? ये 2 से जाके फिर ऐसा 20 dB पर डेकेड, 20 dB पर डेकेड ये स्लोप होगा ऐसा. ठीक है, अंडरस्टूड? Yes or no? Hello? Hello?
Yes, sir.
So have you understood this part up to this?
Yes, sir.
Okay. Okay, so after the internal exam, in the next class we will continue with this topic. Okay, so then we will go to the we will see how to completely draw the entire magnitude plot and then the phase plot. Okay. Okay, so then thank you students for today.